first lesson today. What is a box plot? You're supposed to know this from before, okay? But I never believed that, especially based on who you've had before. I want to teach you my way. Did your teacher call it a box and whisker plot, maybe? No? What was it called? Have you heard? You haven't heard of a box plot? Okay. So, let me take the wheel then. I taught you what a 5-number summary was last lesson. Minimum, median, maximum, and then the Q1 and Q2. A box plot is literally a picture of that. So, that is what a box plot is. You need an x-axis. It needs to fit all of your data. The median line is longer, and that sits where the median of the data is. It tells you where the middle is. The minimum and maximum lines, they're shorter vertical lines placed over the minimum and the maximum. Q1 and Q3 are shorter too. And then the box, why it's called a box and whisker plot sometimes, the box connects Q3 and Q1, so you have a little rectangle in the middle. And then the whiskers are these lines connecting the box to the minimum and the maximum. I'll give you 5 minutes. Can you get that information down about what a box plot is, otherwise known as a box and whisker plot? Your first lesson is just what a box plot is and interpreting it. Then we'll stop, 15 minutes outside. And then the second lesson is about what do we do when we have 2 box plots right next to each other. I'm just going to look at it. 5 minutes. For your notes, you don't have to have that exact scale. You just have to have the idea of what I've drawn up there. Four more minutes. The lines where they're placed right now don't mean anything because this is just a drawing of some random data. Okay? There's no actual data. We're going to practice doing actual data for them. Yeah? Just giving you an example of what it looks like. Do you need something? I'm going to charge. I've got a battery. You're not supposed to plug in. I've got a battery. You charge it down there. I'll bring you the battery. I'll bring you the battery. Couple more minutes. Remember, if you're too slow at writing, it's being recorded anyway. Is that like a USB-A? You need a cable. Couple more minutes. That is a representation and explanation of what a box plot is. We'll practice drawing them from data. You'll practice for 40 minutes. Then we'll go outside for 15. Quick second lesson and that'll be the end of your double. One more minute. All right, from Monday, can anyone remember what we called it when the data, if you had like a column graph, if you had more data on the low end and then it flattened out, that was a kind of skew. Does anyone remember what kind of skew that was? Positively skewed. Well done. So you do remember. That's positively skewed. When it looked the same on both sides, we said it was symmetrical, like that. And if there was more data on the high end, we called it negatively skewed. We can tell the same things with a box plot. So what I'll do is I'll leave most of those notes there for the box plot there. The next thing you need to get is, if you see a box plot that looks the same on both sides, that means the data is symmetrical. Where is the box plot squished up here? Is it squished on the left or the right? Left. That would be positively skewed. Just like this, you've got more data on the low end. This is more data on the low end. That's why it gets squished up. If it's squished up on the high end, it's negatively skewed. You need to be able to use those terms in your assignment coming up. So get real quick pictures of those, please, to tell you what's positively, negatively, and symmetrically skewed. We'll do one example together and I'll finally shut my mouth. If you haven't worked it out yet, how do my lessons work? I show you what I want you to be able to do. I demonstrate what I want you to be able to do. And then you practice what you're supposed to be able to do. Someone already won the sneakers, so I'm considering whether we'll do a second one. Huh? I'll show you. He hasn't been. I need permission from their parents first. Okay? I can't say the name. Just record. Yeah. Because if I do it a second time, that class is quite capable. I might lock them out of it because it's not fair enough. Yeah? Saying we're not capable. Well, show me. Did anyone get 100%? It was open to everyone. All right, consider the data set below. I have a bunch of numbers between 1 and 10. Construct the 5-number summary for the data set. Can I do a 5-number summary if the data is out of order? No. Yes? No. So what would that data look like if it was in order? Read them out. Smallest number, what? 2. Cross it off. Next. Is there other 3s? How many 4s? 3. 1, 2, 3. Cross, cross, cross. Next. There are other people in this class, so you can have a rest. What numbers would come next if I'm putting them in order? 5. How many? 2. 5, 5. There's a few of these. What comes next in order? How many?
5, 6.
2, 3. 1, 2, 3, 4, 5. Well done. Next.
2,
2 sevens, 7, 7, 2 8s, and a 9. That's in order now. I want the 5 number summary. Do I need special maths to work out what the minimum is? What's the smallest number there? That's the min. Min. Do I need special maths or special intelligence to work out what the maximum is? I don't need a formula for that. I just freaking look. So 9 is the max. Now we need to use some of the formula I gave you. I gave you the formula, median is the n plus 1 over 2 th position. How many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 17 numbers. So the median is going to be 17 plus 1 over 2 th. It's going to be the 18 over 2 ninth position. So the median is going to be 1, 2, 3, 4, 5, 6, 7, 8. This 6 here is the median. Why do we have to find things in that order? Because I need to find the median first, because now I've split the data into 2 halves. I've got the upper half here and the lower half here. What's the very center? What's the median of the lower half? How many numbers are there? 1, 2, 3, 4, 5, 6, 7. There's 8. So the median of the lower half is going to be in between 4 and 4. What's the average of 4 and 4? 4. So Q1 is going to be 4. And Q3 is going to be, what's the average of 7 and 7? Also 7. Q3 equals 7. That is all. That's what I taught you on Wednesday. Okay? But the only addition today is that we're drawing a picture of it. So we just worked out the minimum was 2, 4, 6, 7, 9. Let's draw a box plot for that. Do I have a scale right now that's going to fit between 2 and 9? Is that scale going to fit it? So let's draw a short line at 2. Short. Let's draw a short line at 4. What did I do with the median line? Was it the same shortness or was it a little longer? What was it saying, you know? Same? No, a little longer. Median, 6. Let's do a little longer. Q3, 7. Short line, maximum 9. Finish off the box. And then the whiskers go from the middle to the edges there. You can colour it in if you want. You won't get extra marks for colouring. That's a box plot of the data set. Find the range of the data. Range was max take min. What's the maximum here? According to this graph, where's the max? 9, good. Take away, what's the minimum?
2.
So the range is going to be 9, take 2, it's going to be 7. There's a spread of 7 in this data. What's the interquartile range? Where is quartile 3? Where's the edge of the
4.
box?
Oh.
Yeah, 4 is quartile 1. Quartile 3 is going to be 7. So the interquartile range is going to be 7, take 4. The spread of the middle 50% is going to be 3. That's that lesson. So